Today we're reviewing exponential functions. First up, we're going to talk about domain. Domain is all of the possible x values or input values in the function. Sometimes this will be written as a list if you just have like a set of points or a mapping or maybe like a specific type of table, but most often it'll be written in an inequality or you could use interval notation. Remember when we have infinity, we want to make sure that we do less than or greater than for negative infinity. We do not want to do less than or equal to, because you can't be less than or equal to infinity. Range is all your possible range is all your possible y or output values. So again, if you are talking about infinity, you need to make sure that it is less than. Another example, if I wanted to make this over here negative infinity, I'd have to take away the or equal to. For domain and range, we can also say all real numbers if it applies, and that would be saying negative infinity to positive infinity. Next up is an exponential function. Exponential functions are different than linears because linears add or subtract, whereas exponentials multiply either by a fraction or by a number greater than 1. We call that rate that it is changing by, we call that a common ratio. And the template we use for exponential functions is y is equal to a times b to the x, where a is our starting value, or the y-intercept, and b is the common ratio. So b is what we're multiplying by, a is where we start. On this next problem, we're asked to analyze the graph and then answer the following things. So the first thing we want to look for, we're going to write the equation here in a second, but it might be easier to figure out the different pieces of the equation first. Let's start with the y-intercept. My y-intercept is where the function crosses the y-axis. And so if I look here, it appears that it crosses at positive 2. And we need to make sure we write that as a point. Now to figure out the common ratio, I'm going to find some points that are on this function. So 1, 4, 2, 8, negative 1, 1. Okay, so if I make a quick table here, I'm going to do that. X, Y. Here's what I have so far. Oops. Negative 1, 0, 1, and 2. At negative 1, it's at 1. 0, it's at 2. 1, it's at 4. And at 2, it's at 8. So it looks like it's multiplying by 2 for every 1 that it increases. So that means that my common ratio is 2 because it's multiplying by 2. And so my equation would need to be y is equal to, my starting value is 2, and it just so happens that these numbers are the same. That's a coincidence. My common ratio is 2, so that is being multiplied. Another way you could write this, y is equal to 2 times 2 to the x. It means the same thing. Domain is all of my possible Domain's all my possible x values, and so I am looking and seeing from left to right. Well, this is an exponential function, so it would keep going in either direction. And so my domain, since it keeps going in both all the way left and all the way right, my domain is all real numbers. Another way we could write that, negative infinity is less than x is less than infinity. Now my range is a little bit different because my range is up and down. I go to infinity upwards, but going down, I stop at 0. So I have to say that y values are greater than 0. Another way you could say it is that 0 is less than y is less than infinity. It's less than because it actually will never touch that line. because you just keep dividing by half, and 0 is not achieved by dividing by a half, going left at any point. Now for the word problems that we did, now you're not going to use this equation for every single word problem, but if we're talking about percentages, this is when you should use this form. P stands for the principal amount. Which is just a starting amount. R is your percent as a decimal, or your common ratio as a decimal. And of course, T would be time. Let's just make a note. We should only be using this if the problem has percentages. So if you're told that like something doubles or triples, then you know that, for example, doubling is multiplying by 2 or tripling is multiplying by 3. So you should just use the equation that we talked about on the front, and you would already know your common ratio. Don't overcomplicate it. Write the equation for each of these word problems and answer the question. Okay, a business had a profit, a $10,000 profit in 2000. Then the profit increased by 8% each year for the next 10 years. Let's start by changing our percent to a decimal. 8% as a decimal is 0.08. My starting amount is 10,000. So let's write our equation. A is equal to my principal, 10,000, times 1, it's increasing, so 1 plus 0.08. Remember, we have to add 1 because that means we multiply by the starting amount and then increase or decrease from there. Raised to the t. Now I'm going to go ahead and add these up. So that would be 1.08. The question asks us to find the profit after 3 years. So we're going to change our time to 3 and evaluate. So you're going to put this in your calculator. 1.08 to the third times 10,000. When I put that in my calculator, I get that the profit is $12,597.12 after 3 years. Okay, next one. You buy a computer for $3,000. That would be your starting amount. It depreciates. That's a word that means it's decreasing at a rate of 20% per year. That percent as a decimal is 0.20. Find the value of the computer after 3 years. So let's, again, write our equation. My principal is 3,000. I'm going to do, this is decreasing, so 1 minus my rate, raised to the time. Okay, 1 minus 0.20 is 0.80, so let's change that. And I know that my time is going to be 3 years. Again, evaluate in your calculator. I got 1,536, and this is dollars, so I should put a dollar sign. We all missed sequences. We're just going to test you on geometric sequences. Here are a reminder for what the recursive and explicit formulas are. We're going to use that to plug in here. So this problem says to write a recursive and explicit formula to represent the geometric sequence, then find the nth term. So let's look at this problem right now and see what the common ratio is. 500 to 100, that's dividing by 5. But remember, we don't use division for exponentials, and so instead of putting division by 5, I should put multiplication by the reciprocal, 1/5. So dividing by 5, same thing as multiplying by 1/5. That appears to be my common ratio for this problem. So let's just say that really quick. R is going to be 1/5, and I know that my first term, G1, is 500. Okay, let's write recursive first. Recursive, I say G1 is 500, my first term, comma, g to any n would be my common ratio, 1/5, times g n minus 1. You leave it like that. The explicit formula is g to the n, or g subscript n, is equal to g1 is 500 times 1/5 to the n minus 1. Okay, and it wants us to evaluate for the 9th term. It doesn't say after the 9th term, so we're going to evaluate for n equals 9. So g in the 9th term, we're doing 500 times 1/5, 9 minus 1. So I'm evaluating actually to the 8th there. And we're going to plug this in our calculator. Turns out to be a pretty small number. It's going to be 0.00128.